Hello, my name is abdelrahman, and today I'll be solving the first assignment from our dynamics course, which is the kinematics of particles. So, looking here on my screen, question number one. Starting from rest, a particle moving in a straight line has an acceleration of a equals 2t minus 1 meters per second squared, where t is in seconds. What is the particle's velocity and position when t equals 3 seconds? So the first step is to look at the question and take out the important problem, which is a equals to t minus 1. So using the formula we learned in class, dv over dt equal to t minus 1, move the dt to the other side, so it's dv equal to t minus 1 dt. So by integrating both sides and applying limits, and in the integral 3 top, 0 at the bottom, 2t minus 1 dt, which will then result in us getting v equals open parentheses t squared minus 1t close parentheses all to the power of 3 and 0 at the bottom. Then we move to the next step of v equals 3 squared minus 1 multiplied by 3, which results in us getting 6 meters per second as our velocity. This is the answer for the first question. This is a very simple question that we learned in class, and the assignment is also giving us just a small idea of how to solve this question, so it's very simple. Moving on to the second question, question number 2. A particle travels along a straight line with a velocity v equals 16 minus 3t squared meters per second, where t is in seconds. When t equals 2 seconds, the particle is located 9 meters to the left of the origin. Determine the acceleration when t equals 6 seconds, the displacement from t equals 0 to t equals 10 seconds, and the distance the particle travels during this time period. Starting here from the left side, v equals 16 minus 3t squared meters per second, just as we did the last time. So ds over dt equals 16 minus 3t squared. Cancel all commons. C equals 16t minus t to the power of 3 plus constant, or c. When t equals 1 second, s equals negative 9 meters. So negative 9 equals 16 minus 1 plus c. So c equals negative 24. So s of t equals 16t minus t cubed minus 24. So the acceleration a of t equals dv over dt equals negative 6t. So when t equals 6 seconds, a of the acceleration basically of the 6 equals negative 36 meters per second squared. The distance the particle travels during this time period. Let v equals 0, 3 multiplied by t squared equals 16. So t equals 2.3094, or basically 2 seconds. Let's calculate the distance. S of 2 minus S of 0 plus S of 2 minus S of 10 equals, open bracket, 16 multiplied by 2 minus t cubed, close brackets, added to, open bracket, 16 multiplied by 2 minus 2 cubed, close brackets, minus, open bracket, 16 multiplied by 10 minus 10 cubed, close brackets. Putting this into your calculator, you should be getting 888 meters. As you can see, this problem is a little bit more complicated, but we're not done yet. So the displacement from t equals 0 to t equals 10 seconds. So s of 10 minus s of 0 equals 16 multiplied by 10 minus 10 cubed minus 24 minus negative 24, which will then result in negative 840 meters. So as you can see, this question is a little bit complicated, as it was asking for multiple things like the acceleration, the displacement, and the distance the particle traveled. So this problem has 3 different parts, as I showed you and explained to you recently. But the question itself, the question remains as simple as it can be, like if knowing the formula, when formulas and what steps you should take. You just plug in the numbers and they should get the right answers. Let's move on to question 3. A train starts from rest at station A and accelerates at 1 meters per second squared for 70 seconds. Afterwards, it travels with a constant velocity for 10 minutes. It then decreases at 0.5 meters per second squared until it is brought to rest at station B. Determine the distance between the station. So let's divide this into phases. Phase 1, A, or the acceleration, initially was 1 meters per second squared, and u equals 0. T1, or the time at first, is 70 seconds. So looking at the equation we have here, S equals ut1, which is half acceleration multiplied by time squared. S1 is equal then to 0 plus half x multiplied by 1 multiplied by 70 squared, which equals to 2,450 meters. Let's look at the velocity, which equals u plus a multiplied by t, which then results to 0 plus 1 multiplied by 70, which results in the velocity of 70 meters per second. Phase 2, or T2 equals 10 meters equals 10 multiplied by 60, which equals 600 seconds. F of x equal velocity multiplied by time, which is 70 multiplied by 600, which then results in 42,000 meters. Phase 3, A equals negative 0.5 meters per second squared, with the velocity being 70 meters per second, and the final velocity equals 0 because we stopped at station B. So T3 equals V divided by negative the acceleration. So it's 70 over negative 0.5, which then results in 140 seconds. So using this into our next equation, Vf squared minus V2 equals 2as3. Don't mind the scribbles. The formula to use is 146 squared over 2, or divided by 2, which results in 9,800 meters. So let's assume, or let's calculate the total distance that the train took. So to get the total distance, it's very simple as we got it in the phases above. It's S1 plus S2 plus S3, very simple. So 2,450 plus 42,000 plus 9,800, which then equals 54,250 meters. As you can see, this is just a simple problem of finding the distance in multiple phases because the train slowed down, it wasn't on a constant velocity or speed. So this got us the total distance very easily by just dividing it into 3 parts. Let's move on to our next question and final. A ball A is thrown vertically upward from the top of a 20-meter high building with an initial velocity of 4 meters per second. At the same instant, another ball is thrown upward from the ground with an initial velocity of 30 meters per second. Determine the height from the ground and the time at which they pass across each other. So as you can see, as written, we're going to divide it to make it more easier or more comprehensible. So let's take ball A. So it's vertically thrown vertically upward 20 meters. So we put 20 meters. The initial velocity is 4 meters per second, and the acceleration as gravity is pulling it down is negative 9.81 meters per second squared. So SA equals 20 plus 4 multiplied by time, negative half multiplied by 9.81 multiplied by t squared. All of this will result in an answer of 1. Or no, I'm sorry, it will not result in the answer of 1. It's just the equation. So, and let's do the same thing for ball B. So, SO equals 0. The initial velocity is 30 as we saw in the question, and the acceleration is negative 9.81 as stated before. So, putting it together, it's 30 plus half multiplied by negative 9.81 multiplied by time squared. So sorry for the confusion earlier. So when the balls pass each other is the formula of putting SA and SB together and equating them together and removing common numbers and solving the equation basically. So putting the two formulas together, it's going to be 20 plus 40 minus half multiplied by 9.81 t squared equals 0 plus 30t plus half multiplied by negative 9.81 t squared. As you can see in the screen, I have already cancelled the 9.81 and negative 9.81. They cancel each other. And just simple mathematics, or basically pre-calculus, you can just see that 20 plus 4 equals 30, 20 plus 40 equals 30t, or x, and negative 26x equals negative 20, which results in us getting x equals 10 over 3, or 0.769 seconds is the time they pass each other. Let's assume the height. So s equals sb. So we're going to take the equation for the ball B. 30 multiplied by 0.6769, which we got right now recently, plus half multiplied by negative 9.81 multiplied by 0.769 squared. This will get us the distance of 20.1694 meters, and the time, as we got earlier, is 0.769 seconds. Thank you very much. I hope you understood the questions and how I solved them, and the work was shown in a proper and adequate way. Hope I see you next time soon enough. Have a good day.